Then I would like to introduce for our next talk about how to use Knime to analyze near-infrared spectral data, Miriam Mathea. Thanks, Miriam, for joining us today. Hi.
Hi.
So Miriam is a computational toxicologist at BASF, and she's also part of the Chemometrics team. And Miriam, tell us something about the project. So you did that together with Mireille Krier from Merck, who will also join us later in the panel discussion. How did the whole project come up?
Yeah. So the story behind this project is that I had a discussion with Greg from Knime at a conference. I think it was the German Conference of Chemometrics, where I discussed with him that Knime is very popular in cheminformatics, but maybe not that popular in chemometrics, although it could be really suitable for a lot of tasks. And if we maybe try to work on some workflows to change this a little bit. And obviously, he talked with Mireille as well about this topic. And then we talked together, and this is a little bit how this project began.
Cool, thanks. So when you said Knime was not really or is not used really in that field yet, what did you use before? What kind of tools, and what was then actually the incentive to switch to Knime and do it in Knime?
So we are, at least in our team, we are mainly using R and Python and also MATLAB. But I think it's also nice to have Knime as an additional tool available to, if you maybe do not really work really deep on some specific optimization of some functions, but maybe to get a good overview of your data. And also, yeah, of course, a lot of lab team leaders know their data really well, and for them, it could be also very suitable to execute some workflows for data visualization. And also, in addition, it's also a very nice tool also to use or to share with the lab technicians as well. And yeah, some of the analysis are also you're doing in a repeating way. This is also can be very good organized via and shared via Knime workflows. So at least from my point of view.
Cool, nice. So I would say then let's have a look how to do chemometrics with Knime.
Yeah, thanks. As you already mentioned, I would like to give a short overview on how to do a little bit chemometrics with Knime. So analysis of NIR data. And yeah, I want to now it's working. I want to start with a short summary. So in general, NIR or near-infrared spectroscopy and chemometrics are broadly used in we have a lot of applications, mainly in pharmaceutical industry, chemical industry, but also oil industry, and it's often used for qualitative and quantitative analysis. And the advantages are the low cost, the non-destructive characteristic towards these analyzed samples, and also in contrast, for example, to mid-IR spectra, they are especially the absorbent bands directly interpretable. Due to this chemical peak specificity, NIR spectra are a little bit more difficult to directly interpret, and that's why chemometrics are really useful to work with as NIR spectra. And the main methods to work with these spectra are mathematical pre-treatment methods, classification methods, and regression methods. And now the point why we thought that Knime could be really useful for this is that a lot of nodes and example workflows are already available for classification and regression models. And I think the only little bit missing part were the mathematical pre-treatment methods. And that's why we decided to work on this and maybe show some example workflows. The first workflow I want to introduce is now directly about mathematical pre-processing. So yeah, how do we start? is it, first of all, if you have then your data, of course, you start reading in your data, then you do this classical preparation, splitting, cleaning up. And then now with this example workflow, you can, this is available. We share the link as well. We also, I don't know if we already mentioned it yet. So we worked on a blog post about it, and there we also share the link as well from the blog post, and there you can also have a deeper look on the workflows, and there's also a little bit explanation. So in this workflow, again, you can then select specific, after reading in your data, you can visit the spectra, you can select specific areas, and you can have a closer look on the spectra. And then we came to the part, then you can here select your pre-processing methods. I know this is only a very short selection of processing methods. We just wanted to use this as some kind of starting point. Wanted to have at least one representative for these two main representative of pre-processing methods, one from the scatter correction methods and one from the spectral derivatives. And that's why we came up with some classical centering, scaling, standard normal variate, and Savitsky-Golay filtering. And of course, we would really, or I would really like to introduce or include more methods, for example, like multiplicative scatter correction, but I think this can also some things that can be done in the future as well. So after the selection of the pre-processing methods, you can also, again, have a look on your data. And then, in principle, the idea would be that you can then use further Knime workflows to then really work with your data. For example, you can visualize your pre-processed data. As I already mentioned, Knime already has a lot of opportunities to visualize data, to use some unsupervised methods to really inspect your data. Here on the right-hand side, you can see an example of a PCA. So we use straw samples content, and but of course you can replace it now with any other data set. I just want to show that, for example, with such a PCA plot, you can then maybe have a look if you see any clusters in your data. If you color it by a specific property, you can have a look if you maybe see some patterns. Do you have this matching of colors and specific clusters, or do I maybe observe some specific outliers in my data set? In addition to a PCA analysis, you could also, or alternatively, also do some cluster analysis as shown here. And of course, you can also do some simple plotting of your spectra, maybe with a specific offset. This is possible as well. Here with the top part of the workflow, you can select the spectra you want to visualize or plot, and you can also select the offset. And of course, this is only a selection. Of course, what you can do, feel free to combine it with any other asset already available. And what you can do as well is, for example, doing similarity search with spectra. If you have, for example, a small in-house database or data sets available where you maybe have a new spectrum and you want to compare it with the already existing spectra in the database, you can use a workflow like this. And here you have the possibility to select any distance method you want to use for similarity search, and or a Pearson correlation coefficient, then you can select specific wavelength regions, and you can also customize the parameter K, for example, to select how many nearest neighbor spectra should be come out of this analysis. And you can also, with a slightly modification of this workflow, you can also do it a little bit the other way around. For example, if you have a data which you consider maybe as this norm, somehow normal, you can also specify, for example, a distance-based threshold, and then you can in principle check whether a new sample or new spectrum is with this normal variability range. And what you can do, of course, also, and this is also, I think, one of the real strengths. And now, if you have your pre-processed data, you can also build any classification or regression model on top of it. Of course, there are really broad range of applications where this can be useful. Only to mention a few of them is, for example, to analyze physical properties like particle size or moisture determination, or you could also work on the analysis of bioprocesses. So the range of applications is really, really broad, and it's really, really convenient that there are already a lot of different workflows available to demonstrate some classification and regression tasks, and also to feature selection as well. Because, as I already mentioned, maybe for your model, only specific parts of the spectrum are maybe of interest, or the model performance increases if you maybe only use a selection. But this is of course possible with this already available Knime workflows. You can feel free to combine every pieces if specific for your task you want to address. What specific project you want to work on. And with this, I would really like to thank Mireille and Tamascan to work on this. It was really fun. And also, of course, Knime, to have the opportunity to introduce this here. And I would be happy if this is only the start to do some chemometric with Knime, and that more people maybe will work on this and maybe contribute to this. Thanks. I think this is all.
Thanks a lot. Very cool, Miriam. You were already talking about that earlier, that using Knime would not enable only the data specialist or the expert to deal with the data, but also, for example, to other people. So how was, when now you have these really cool workflows, how was the adoption within your team?
Mm-hmm. Yeah, I think this is also one of the real big advantages of Knime. So this is maybe one example from my chemoinformatics team. We're also using a lot of Knime workflows. I have, for example, a 60-year-old lab technician who was a little bit scared to now work for the chemoinformatics team, but she really likes Knime, and now she's really into data analysis. And I think somehow the hurdle to work on these specific topics is a little bit lower, but so for her, Knime was a really good solution to get into the topic, and now she's really advanced. It's really nice to see.
Very cool. So nice to hear that. Janina, do we have any questions from the audience?
Yes, so there's the questions, are there other data types, or in brackets, other spectral data that could be integrated as well in your workflow?
Yeah, in principle, now it's, of course, a workflow that is a little bit more specified for spectroscopy data. If you think, for example, of chromatographic approaches, you would, of course, need some other pre-processing methods. This would be now not possible with this workflow. But we thought that, as I already mentioned, that this could be maybe only a start, and maybe in the future we could also work on further data types like chromatographic data, and maybe also work on some workflows or pre-treatment workflows they can deal with this data as well.
Cool. Thanks a lot.
There
Is there
one
no more
comment.
question?
Yeah,
Is there
from
another
the
question?
audience. Yeah, more or less a comment from Mark Earl. He said, very nice work for spectral data. It would be nice if Knime had a native PLS node. However, I've written one based on R, just as an information, I think we share.
Yeah, I agree.